Welcome to the ObjectFX Getting Started with Spatial Rules demo. The objective of this demo is to provide developers with the information on how to begin utilizing the Spatial Rules SDK directly in a custom Java application. ObjectFX Spatial Rules is a commercial, off-the-shelf, service-oriented product that integrates with custom applications to extract useful information out of large volumes of time-stamped geospatial data. It uses concise business rules to detect patterns, events, or conditions of interest to the user. Spatial Rules offers many benefits. With a focus on efficiency and speed, it can monitor large volumes of data in real time as it is collected and produce immediate results. Over 10,000 objects can be analyzed in less than 1 second. Spatial Rules is designed to be highly flexible, performing analysis across multiple data sources including static to static, static to dynamic, and dynamic to dynamic, accepting multiple data input formats such as KML, GML, shapefiles, and GORSS, and integrating with existing or new viewing applications within any development environment, including Java, .NET, Python, Ruby, and others. Spatial Rules also provides monitoring and analysis continuity throughout changes. Business rules can be adjusted at any time without interruption to the service. With Spatial Rules, policies and standards can be enforced. Forensics based on previous or current experience can be automated. To demonstrate the fundamental concepts of Spatial Rules, I'm going to review and run one of the basic console example applications. I will start with the default input files and then update the application to use the sample KML files created in the previous demo. The Spatial Rules example tutorial is distributed with a zip file that contains the following: examples folder containing the source code, KML inputs folder containing the default input KML, live folder containing jar files, schemas folder containing XSD files for reference, and a README file containing system requirement and installation information. After setup and installation are completed as outlined in the README file, one can begin running the example applications with no modifications needed. Before running the basic example with the default input files, I will quickly walk through the code. The example code integrates Spatial Rules services directly into an application. We'll start under the Run Example method. Here, the first few steps are set up. An instance of the rules database is opened and any previously loaded data is cleared out for a clean run. A result listener is created and subscribed for all rules expressions, and the rule service is started. Next, the input reference KML file is parsed and the reference feature loaded into the rules database. Then the spatial rules expressions are defined and added to the rules database. For this scenario, the within rule is defined, which will evaluate to true if a subject is found to be within a target feature. After the reference feature and rules expression are loaded into the database, the rule service is refreshed to pick up these changes. Once this is complete, the dynamic features are ready to be processed and submitted for evaluation against the rules expression created. Here, the input dynamic KML file is parsed and the features are submitted to the rules service. For this example scenario, if a dynamic feature is found to be within the reference feature loaded, then a result is generated and received by the listener. In the example implementation of the result listener, which is the My Result Listener for this example, the result is printed out to the console and a results text file. After all dynamic features are processed, the result listener and rule service are shut down, signaling the end of the application. The KML files used in the example are set in the main method. The zone and route KML files are the default inputs for this example. The data in these files can be visualized using Google Earth. When the example application runs, we would expect to see a result for every dynamic feature point found within the target reference. Here we would expect to see a result for every yellow icon that lies within the shaded orange area. Zooming in, we find one SP2 and 3 SP1 objects within the reference area. Now let's run the example to see the results generated by Spatial Rules. 4 result events have been generated as expected. 1 SP2 and 3 SP1 dynamic objects have been properly identified by Spatial Rules as being within the target feature loaded. Next, I'm going to run this example using the sample KML files created in the separate demo. I added the sample KML files to my project, updated the files being set in the example code, and modified the reference feature ID and type to be relevant to the new reference feature. I also chose to update the Spatial Rules expressions used to be the enters and exit rules. Now I'm ready to run the example with the new input and updated rules. For this scenario, 2 events have been generated. Object A, point 2, has entered the reference area, and Object A, point 5, has exited the reference area. Reviewing the input data using Google Earth, this is the expected results. This is point 2, this has entered the reference area, and this is point 5, which has exited the reference area. This concludes covering the basic concepts of using Spatial Rules. Examples 2 and 3 use live stream data, so you'll want to check them out. There are also additional advanced features not covered here that you may want to explore. For a more in-depth analysis of Spatial Rules and to learn more about the additional features it provides, please review the Spatial Rules Developer's Guide found under the doc folder of the Spatial Rules trial download. If you have questions and want to learn more, please contact ObjectFX customer support.